I have been talking a lot about computational design and programming in architecture, so I wanted to give you a glimpse of what I'm working on and how automation can be used for short-term thinking and for long-term thinking. And especially these long-term things are very important for me, these long-term plans. So I've kind of consolidated the work on all of the different projects that I'm working on, and I divided this in these 4 directions, in 4 categories. And I kind of created this small graph for myself. So I would like to share that with you and hopefully inspire you to work on similar things, or maybe even give you some tips and advice on how to proceed on them. At the core of everything we do is computation and automation, right? That's what you see in this graph. And let's start with the upper right corner. I wanted to use computation and automation since the very beginning, since I started to reach this holy grail in architecture, which is custom design and yet the efficiency of prefabrication. We all know that there was a lot of attempts in the last 100 years or more to do these modular prefabricated houses, especially for housing, for living. And usually there was this trade-off, right? If something is modular and prefabricated, it's the same. It's copy-paste, it's cookie-cutter, right? So since the beginning of my computational design journey, I was saying, no, that's not really, that's really the possibility that computational design opens for us is that we can move the modules to the software. So now the software becomes modular. So we have functions and classes that we feed with different variables, but you can end up with custom design, like 1,000 different houses, yet they're automatically ready for production in the same way as a prefabricated house would. I wasn't able to implement this until Cosmic, right? I'm a part of Cosmic Buildings, and there we have a lot of innovations, including a lot of use of AI and robotics. And I will show in the future how we're creating. I'm trying to program this house configurator where we have exactly that. We have just with a couple of variables we can design custom-made homes, custom-made houses with. And everything, make everything ready for production at the click of a button. So that's one direction, right? I'm going to expand on it in the future, show you a lot of Cosmic Buildings. We're building the houses in Los Angeles right now. You will see the houses being built, so on and so on. That's one direction. Another direction that's very important to me is to stay in touch with nature. We are working on this research project called AlgoLoam, where we're trying to create a system in building loam walls. If you don't know, loam is kind of a clay. So they're 100% recyclable walls, reinforced with natural fibers. That means natural plant fibers are inside, reinforcing them. You can literally take the wall and throw it in your yard and it will decompose. It's 100% recyclable. And that's a very ambitious goal we set for ourselves, but we are doing that, and there's a lot of computational design involved that, which you will see in the future. There is a lot of optimization algorithms, pattern generation, geometry generation, structural design in a loop included in the optimization. There is a lot of life cycle analysis, that data embedded, and I can't show much of it now, but for me that's important because working on this project, we're really in touch with nature. We remember how to build with earth materials, with plant materials. We're literally touching the earth and the clay and the plants. We're building models and so on, because that's the part that I think should not be forgotten in the future. And the computational design tools can actually be used not to necessarily go only in this futuristic scientific direction, but to get back in touch with nature. So as I said, I'm not going to expand on each one of these in detail. You will see that in the future, but now I'm giving you an overview. So we covered 2 of the fields that I'm working on. Now we go to this left lower corner, which is, I wrote there like precision and responsibility and the future, basically complexity. And that's one of the basic things that I work on. And if you know me, that's what you know me for. I worked on a very complex project in the last 15, 20 years, from the Shenzhen airport over the Kuwait International Airport, different projects designed by Foster, by Zaha Hadid, by Massimiliano Fuxas. We worked on the Las Vegas Sphere, as many of you know, and so on. Very, very complex and free-form objects. And we work a lot on these facade structures, right? For me, that's important because computational design, that's something that I usually call serious computational design, where the precision is really high. So when we prepare this fabrication documentation for complex structures and for facade elements, we really model every screw with a thread on it, every hole. We're working with 0.001 millimeter precision. And the responsibility is very, very high. So that means our mistakes can cost millions of dollars if everything goes to the machine and gets produced. So this is the part of the work that's forward-looking, that's futuristic. But it shouldn't be just about some building crazy structures. It should be all connected, which leads me to the fourth quarter and my work with architects. I work with this architectural office called DTFLR. They're in Austria and Germany and a couple of other countries. And they care a lot about sustainability and circularity. I wrote Spaceship Earth here with the idea of Buckminster Fuller that we should and could observe the entire Earth as one single thing, as one spaceship flying through space. And that's where these ideas of sustainability and circularity come in. So in cooperation with architects, I'm developing a lot of tools, some of which you will see in the future, some of which you will be able to use to enable this kind of sustainable and circular approach when building. Not going to say much about it right now, but it is all connected together. That's the most important thing. The computation and automation can allow us to create these tools on different levels and on different scales. In this lower left corner, as I said, we're dealing with 0.001 millimeter precision with high responsibility. Yet again, when we work with architects, we can easily work on a scale of a block or several blocks, right? So we can work with scales of kilometers and not 0.01 millimeters. So this is a basic overview, and the important thing is that I put this outer circle around it that says intelligence. And that is for me where AI comes into play, because computation and automation is relatively deterministic, but in our practice, we start using AI more and more. Now, I talked about this in other videos, and we'll talk about it in the future. There's a lot of hype about AI, and 90% or more of the use of AI in architecture is in rendering and visualizations, which I'm not interested in that much, although we use that a lot in the cosmic buildings. But there is this intelligence that connects all of that together: the AI, the robotics, the life cycle analysis, the precision, and so on. And it's kind of creeping in with different tools and the connection of those tools. So we'll talk about that in the future. I'm not going to expand on it now, but it's important for me to represent this graph in that way, that at the core of it is this deterministic computation automation, and then we add this layer of intelligence on top of it that connects all together. And I keep seeing more and more of this talk about space and how we will, as a civilization, we will expand into space, and I fully believe that will happen. I think everybody kind of agrees on that. And there was some talk about space architecture in the past, and there were some designs and so on, which are kind of hypothetical and theoretical so far. But I see space as a very, very, very interesting field where we can expand with our knowledge. So that's kind of the next frontier. But we'll talk about space in some other video. This is the collage of different scales and different applications of computational designs that I created for myself, and I invite you to be a part of any of it. Just write to me, contact me if you're interested. I will make more videos about this. You have the Rhino Developer Courses on my YouTube channel for free that you can listen to if you want to go more into this direction of computational design. And I wanted you to see that it's important to create this long-term thinking, long-term plans, and this story that connects everything, because that's what will keep you going forward, and that's what will always hold your whatever you're doing, keep you on the right path. I started rambling and babbling, so I'll stop here and I'll see you soon. Stay free. No, wait. Subscribe, right? Subscribe. Liking is not important, but subscribing and following is important. YouTube, LinkedIn, even Instagram. So yeah, Talk to you soon.